Okay, today in class we talked about graphing linear inequalities. So we're going to be looking at how to graph a line that doesn't have an equal sign here, but instead has one of these inequality symbols that we're used to seeing. Everything is basically going to be exactly the same. Your m is still your slope, and your b is still your y-intercept. And on a graph, that's where you are going to put your first point. Now the only difference is what the line is gonna look like, as well as where your shading is gonna be happening. We had talked about when we had a symbol like this, like a greater than sign. When we had just solved equations, this used an open circle, and then it would draw a line greater than. This one was an open circle, but would draw a line to the left. This one was a solid circle, remember, with the or equal to, and would go this way. This one would be a solid line going this way. Well, it's similar to that when we were solving just equations with just an x in them and plotting them on a number line. But now we're going to, instead of using an open circle, we're going to use a dashed line like this. And a solid line should look exactly the same as our regular line. But we're also going to be doing some shading. If it's a greater than, we're going to be shading above. If it's a less than, we're going to be shading below, and so on. So let me show you what we mean. Here's a problem from class. We're going to start by just graphing this exactly how we already know how to do it. We're going to start by plotting our y-intercept of -3. So this crosses the y-axis at -3. Then we're going to look at the number that multiplies x, and that's our slope. So in this case, we're going to be going up 2 and over 1. So I'm going to keep going up 2 over 1 to find all of these other points on the line. Looks like I can double back and find one more. Since my inequality is less than or equal to, I'm going to use a solid line because it's or equal to. And since it's less than, I'm going to shade the graph underneath the line. Okay? This shading area represents all of the solutions, all of these ordered pairs in here that will make this inequality true. For example, I'm going to test these inequalities down here. 0, 0. Let's plot that point. And you notice it is not in the shaded region. That means when I plug in for x and y, 0 and 0, it will make a false statement. 2 times 0 is 0, minus 3. It's saying 0 is less than or equal to -3. Well, 0 is not less than -3, and that is not true. This is not one of the solutions, and one way that you can see it visually is it ends up on the graph. It is not in the shaded region of the graph. Okay, let's look at maybe one that does work. If I go to the ordered pair 3, 1, notice this one does fall in the shaded region. That means that when I plug in x and y, I'll just show you here, this should work. 1 is less than or equal to, the x value is 3, minus 3. So 1 is less than or equal to 6 minus 3, which is 3. And that's true, 1 is less than 3. So this one is also going to be one, this is going to be one that works. -1, 5 is up here somewhere. That's definitely not in the shaded region. That one's not going to work. So the other examples like this will be done exactly the same. Okay, you start with your y-intercept, count your slope. This one would be a dashed line. So this one starts at 3. We go up 1 over 2 every time. Backtrack a little. Notice this one is a greater than. So that means it's going to be a dashed line instead of a solid line. And our shading is going to be, since it's greater than, we're going to shade above. Okay? If the question asks to find these different points, we're just going to check them. So 0, 3. Notice this one falls on the line. Well, just like when we did regular inequalities with one variable, if it fell on an open circle, it wasn't going to be a solution. So this one is not going to work. 6, 5 falls right here, and that's not in the shaded region. -2, 4 falls right here. Notice that is in the shaded region. So this would make a true statement had I plugged it in and checked it that way. Okay? So the other ones on this page are just like that. On the back, we have a little bit of a problem because these are not in that slope-intercept form that we know and love. We want these equations to look like this. where I have a b of a y-intercept and I have an m. So all we're going to do is manipulate this inequality so it looks like that. We want the y alone. Well, the y is being multiplied by 2, so I can't separate those guys right now, but I can move the 2x to the other side by using opposites, right? We're going to cancel it on this side, which means we subtract it on this side. 6 minus 2x. Okay, I cannot combine those because this one's just a 6 and this is a 2x, so they cannot be combined. The last thing I have to do is divide everything by 2. So I'm going to divide everything in the problem by 2. Notice it's twice the y value, which I only want one of those. 6 divided by 2 is 3. 2 divided by 2 is 1. And I would go from here to plot. Start at 3, down 1 over 1 every time. Solid line. And I would be shading below. I want to look at 1 where we end up having to flip the sign. Here's one. In number 10, I'm going to move the 8x to the other side. And now I'm going to divide everything in the problem by negative 6. Okay, this cancels. Just like when we solved inequalities, whenever you divide both sides by a negative, you have to flip this sign around. So right now it says less than or equal to. We're going to change that to greater than or equal to. 12 divided by negative 6 is negative 2. And this isn't going to divide evenly, but I do end up with a negative over a negative is a positive. You can either leave it as 8 over 6, or you notice that both of these numbers are divisible by 2. And I get 4/3 x. Again, your calculator using the math button will do that for you if you're having trouble doing that by yourself. So where am I going to start? I'm going to start at negative 2. I'm going to go up 4 and over 3. I'm going to backtrack. This is an or equal to, so again, it's going to have a solid line. My shading is greater than, right, because I had to flip the sign. So all of the ordered pairs that fit out here, all of these, are going to work. If I plug in the x and y, it will make a true statement. And that's what we did today with graphing linear inequalities. I hope that was helpful.